take a look at some more of this. So implementation flaws. Often you have a login system where you can put in something like an invalid password and it will let you in. This happened in some of my CTFs in the early days. There were some forms that I implemented incorrectly. Students found out you could put in a blank entry and it would come out as true. This sounds stupid, but it's a lot easier to make this mistake in coding than you would think. Then often there's multi-stage login, where you have to put in username and password, then like a CAPTCHA, then some value displayed on a token, and just like the resetting password, this is a complicated process with several steps, and it's easy to do them wrong. One thing you might be able to do is skip steps. So you might have page 1 where you put in username and password, page 2 where you put in like the token number, and page 3 where you get in, and you might be able to just skip over step 2 and jump to step 3. That's called insecure direct object access, and you'll see it in the hands-on. I'll demonstrate later. You also might be able to mix data from one user at one step with data from a different user at the other step, and things like that. There's a bunch of ways to do this wrong. You might use a randomly chosen question to verify the user. This was when two-factor authentication first came out. They would do this. They would say, like, write a caption for this cartoon, and when you come to our website, you'll see your caption, and you'll know it's you. I never see anybody doing that anymore, but that was one of the early stages. But this might be in a cookie or something you can modify. And then, of course, insecure credential storage. One thing a lot of people do is just put the plain text password in a database. You can steal it with SQL injection. That's a really bad idea, a very poor. What you're supposed to do is hash it. Now, some people use like 1 round of MD5 or SHA-1 to hash it, and that's hardly any better than storing a plain text password, because these password hashing functions are so fast that you can try a list of 100 million passwords and calculate all the hashes until you find it. So what you're supposed to do is salt it and stretch it, which we'll talk about later. So here's considerations for authentication. How much security do you want? Because to make it really secure, you're going to irritate the users more and more. So you have to make a balance between convenience and security. Basically, it's going to cost you more money to have a secure system. It's going to mean more users are locked out, and they're going to have to suffer more to get back in if you have a really strong system. And you're going to have to decide how much money do you really want to spend on password resets and stuff like that. Strong credentials should have passwords requiring a certain number of characters and a certain number of characters and certain types of characters, avoiding dictionary words, and so on. So protect your passwords when you create them, when you store them, and when you transmit them. Don't write your own cryptographic systems. Just use standard stuff like SSL. The whole login page should be encrypted, not just the login button. You use post instead of get. And don't put anything sensitive in URL parameters or cookies. All the cookie should be is a random number, which means nothing except to your server that knows what it means. Nobody should be able to find any useful data in that cookie. So don't transmit credentials back to the client, and hash the credentials you're storing on the server. These are good practices. And that means you have to salt and stretch it. You salt it by adding random characters to the password before hashing it, so that if 2 users choose the same password, they'll have a different hash. And you stretch it by doing many rounds of hashing, like 5,000 rounds of SHA-512 is what Linux does by default. And that means it takes something like 20 milliseconds to calculate a hash. And that is not going to irritate a normal user, but it means an attacker is not going to be able to run millions of passwords in a reasonable amount of time. So this makes your storage of makes it harder for people to crack the hashes if they steal them. So this is the login.defs file from a Kali Linux machine showing they use 512 and they have 5,000 rounds by default. The Mac is the same. 5,000 rounds of SHA-512. Microsoft uses 1 round of MD4. They are 25 years out of date, probably now 30 years out of date on their password security. It is pretty incredible. The Linux world figured this out in 1975, and Microsoft still did not get the memo. Anyway, so remember me functionality should remember only unimportant things like username, non-secret things. If you allow users to store them, they should be reversibly encrypted with a key known only to the server. I wish people that wrote Android apps knew this. I've never seen any Android app do this at all. Half of them store the password locally, and they all store it insecurely. So, like I say, it's a recommendation to force users to change passwords periodically, but that is no longer recommended. All right, if your new users should get a password that's time limited, where they have to change the password at first login. And one thing you might do is use GUI instead of typing if you're worried about keyloggers. I don't know if I've seen anybody do that, but they say that. If you make them choose things off a list, then a keylogger won't catch it. All right, validate the whole credential with case sensitivity, terminate this session on any exception, and control user impersonation. So at a multi-stage login, the right way to do it is you should hold all the data on a server-side object. You shouldn't believe the client. You shouldn't let the client at step 3 include a cookie that says, I finished step 2, or they can forge that. The server should know how far you got, and what you should do is always make them complete the entire login process and then give them an error message. Don't tell them you failed at step 1, you failed at step 2. That's the problem. All right. And so authentication failures should use the same code to produce the same error message. Otherwise, you're likely to have some subtle difference in the error message or different conditions that can leak out information. And you should lock them out for username. Login attempts with invalid usernames should read the same error message as valid ones. If you allow them to self-register, like most people do, then they'll use standard usernames. You could generate unique ones or use emails. I'm not sure I see the point of this. Your book talks about it. It all seems quite similar to me. Anyway, brute force attacks. There are any place where the password is used, might be used to guess the password. So you should block them out if they guess too many times at any of these places. So your high security app might disable your account, and then you have to physically go to a customer service rep. Most people are not willing to do that. So what they do is just lock you out for like 30 minutes. That's enough. Then you might come back in 30 minutes, try another 10 times or something. That way a normal user will eventually find where they wrote down their password, and the bad guys cannot guess thousands of times. However, one thing that is almost impossible to stop is a password spray, where instead of trying one username and many passwords, you just choose a common password and try many usernames. Now, you're not going to get locked out because you keep logging in as different people, and you're just counting on somebody using a standard password. This is quite common. And so the defenses against that are going to be strong password rules, so not using those passwords, and a CAPTCHA is more like it, where they actually have to have a human physically enter every one. Although all CAPTCHAs have been broken, there are various ways to break them. One of the simplest ways is Mechanical Turk. You just pay somebody in a foreign country that will work for cheap to solve the CAPTCHA for you. You can get these solved for like a couple pennies each. There are also a bunch of Russian cybercrime forums where someone will sell you code that will break the CAPTCHA. With modern AI, they can break almost any CAPTCHA. But it does slow people down. It stops a certain type of attacker. All right, there should be no way to change your username. You should have to put in the old password to change it, and again, have the same error message for all failures, and notify the user when their password has been changed, because that might be a clue that someone's breaking into their account. And account recovery is the same kind of thing. Email a time-limited, unguessable, single-use security URL to the email account of record. Don't let users write their own questions. Don't let them choose questions with too few options, like your favorite color or a yes or no question. And as always, don't just let people do things over and over and over again wrong. Like the attackers, if they fail a certain number of times, realize you're being attacked, and then lock them out. And put it in your intrusion detection system. It should alert, maybe block that IP address, maybe tell people they're trying to get in, that sort of thing. You should recognize security events in the authentication system and deal with them seriously. All right. And so let's take a look at the C here. All right. How bulletproof are user authentication platforms like Firebase? I've never used Firebase, so I don't really know. It's an interesting question. I know there are some authentication platforms where the platform got hacked and therefore exposed a lot of companies, sort of like this LastPass hack. But I don't know Firebase. I think Okta is one that got hacked about a year or two ago, and all their customers were therefore in trouble. Although I've never used it, I just read about it, so I'm not really sure exactly what they do. Yeah, it could have been. Another thing that's quite common is companies don't really get hacked. They just find a dump from somebody else and then they use those names and passwords because people reuse passwords. That's quite common that people get into a system, but they didn't actually breach that system. That's why everybody should use a password manager. You should really have a different password at every site. What router would you use as a secure extender? I do not know. I cannot make a recommendation. I'm not much good at shopping. I know home and small business routers tend to be insecure. There's usually ways to get in. Yeah, use WPA or WPA2 or WPA3. Sure, you should certainly do that. All right, so what system might let you log in with a blank username? Fail open login. You know, I remember how this happened to me. I wanted to take a substring. And if you do a substring in C or Python, the substring either tells you the location of where it found the string or -1. In PHP, the substring function gives you the location of the substring if it's found, and if it's a number, and if it's not found, it gives you a Boolean false. I've never seen a function like this in any language, where it sends one data type for true and a different data type for false. So when I compared it to something, the comparison lets you in with a blank entry. You really got to read the docs, which I did not do. Anyway, that's fail open login.
What is fail open login?
Fail open login is where when you put in something that confuses the server, it lets you in. Like you put in a number instead of a letter or a special character or something. So an exception leads to falling through. Yeah. Yeah. All right. All right, so how should credentials be stored? Hashed, salted, and stretched is the best way to do it. It's not perfect, by the way, so even if people steal your hashed passwords, they will eventually begin succeed in cracking them, but it gives you some time to respond, like force a password reset or something. All right, so what should happen if you fail at the first stage in a multi-stage login process? Complete the whole process and then show an error. Otherwise, you're making it possible for them to guess the different stages separately. All right. All right, so what function should use auto-generated usernames to prevent enumeration? So this is a recommendation in the book. I've never seen this done in practice. I'm pretty skeptical of it. It might be secure, but I think it's too inconvenient. That's self-registration. All right. right, Austin. And Pete. Okay, all right, good. All right, let's stop this recording.